Okay, moving on, question 15. Find a real non-zero solution to the equation 2 to the 9 to the x over 8 to the 3 to the x equals a quarter. Okay, so they gave you some brackets to clarify that. I mean, normally, even if the brackets aren't there, you would assume that it looks like this. Even if the brackets aren't there, you deal with the power on top first. Okay, so what do we do? I mean, there's an exponential equation, right? So always same strategy. The strategy is convert to the same base. I mean, I don't have to say this at this point. Okay, so same base. What is the common base? The common base is 2. Always convert to the smallest base. If you convert to the smallest base, you avoid all sorts of fractions. Okay, good. So 2 to 9 to the x, no change needed there. Divided by 2 to the 3 times 3 to x. Because 8 is 2 cubed, equals 1 over 2 squared. Lovely, so now the bases are all 2's. Okay, next thing. Well, we hate fractions, so let's get rid of them. So we have 2 to the 9 to the x times 2 squared equals 2 to the 3 times 3 to the x. Very good. Okay, so now we, laws of indices, this is 9 to the x plus 2, this is 9 to the x plus 2. So, therefore, 9 to the x plus 2 must be the same as 3 times 3 to the x. Good. Okay, again, this becomes a very, very classic equation, right? What equation is this? Needless to say, it is a quadratic. It is a quadratic. Very good. So, quadratic in terms of 3 to the x, of course. So, 3 to the x, all squared, that comes from 9 to the x, minus 3 times 3 to the x. So, that's the coefficients, for the b in the quadratic. Plus 2 equals to 0. So factorize 3 to the x minus 2, 3 to the x minus 1 equals to 0. Good, and then what do we have? So either 3 to the x is 2 or 3 to the x is 1. And remember, x is non-zero, x is non-zero. So therefore, this guy is not possible, because 3 to the power 0 is 1, 3 to the power 0 is 1. Okay, so therefore we are left with 3 to the power x is 2. What does that mean? That means that the final answer will be log base 3, 2. So answer will be A. I mean, normally, when I teach people, when I teach my students sometimes, like here you take LNs instead, because I think LN's a much better option compared to log base 3. It's just ridiculous, I think. Like, I would much prefer people doing this. Ln both sides, and then the x comes down, right? So then there's x ln 3 equals ln 2, and then you divide ln 3 over. And of course, numerically, these two things are the same, but I much prefer the ln. Maybe it's a personal preference, but I think it's much more elegant when you use ln, right? Especially when you deal with exponential equations with different bases. Then you should take ln's on both sides. Okay, either way, enough of me going on there.